Okay, on behalf of my group, I would like to present to you our topic. We were looking at how to optimize the water usage during the cleaning process. So, of course, first, why do we need to even reduce the water usage? Why do we need water in the first place? We are using deionized water during cleaning and several other processing steps of wafers to, in this case, to remove the wafers from contamination and, of course, to keep up the good quality of the wafers or the produced chips. In order to do this, the water needs to be purified before that. And this is a very intensive process. It requires a lot of energy and chemical usage. Therefore, by reducing the water amount, we are also removing or reducing, of course, the usage of these two things as well. And yes, here on the right side, you can see several, well, we call them recipes. So basically, the exact processing steps or the method of cleaning the wafers. And on the very far right side, you can see the amount of water which each of these, like total amount of water which is consumed for each of these individual recipes. Yes, so next slide. Okay, so what exactly did we do? We analyzed data which looked like in the table, which is shown here, for the ongoing year. So data for processed wafers up until last week, I think, yeah. And what we could see, or like the data which we received was first containing information on the exact date of the processing of a batch of wafers, and at which time those wafers were being processed, and the name of basically the box of wafers, which is referred to a lot, and the quantity of wafers inside one lot, and which recipes they were using. One lot can contain up to 25 wafers, and we checked and saw a lot of optimization potential because we saw that a lot of wafers or a lot of lots were being processed which were not at full capacity. Here you can see 5 lots being processed on the 8th of January, so the very first date, or yeah, third date of starting on our analysis. And only one of them was containing the maximum number of wafers, whereas 4 of them were containing only 5 wafers. So we could have easily merged 4 of these lots. They were only being processed within like 5 hours of each other. So we were thinking how much water can we actually reduce by combining, for example, in this case, those 4 wafers. So we gave a maximum waiting time between those lots being merged for 8 hours. Okay. Next. And what we found, first of all, we checked the amount of water being used for each of the recipes for the last 8 months. And so in the dark blue, you can see the amount of water actually processed in the last 8 months, whereas in light blue, you can see the, well, optimized potential, so to speak. So like by merging those wafers within 8 hours of time, how much water would have been used instead. So you can see that a lot of these, or like basically all of those recipes could have been easily saved some water. Yeah. And the number above them tell you how many runs they had, each recipe had, because actually the water consumption is not dependent on the number of wafers inside those lots, but rather per lot itself. Okay, next, please. Okay, so this shows you how much water would have been saved by using our method, by merging several lots. And you can see that it's like quite a significant amount of water, which could have been saved within the last 8 months only. This is a reduction by 23%, which amounts to about 300,000 liters of water. Yes, next please. Okay, so of course, as I mentioned before, it may obstruct the processing of the wafers if we are waiting 8 hours for the next lot to arrive before processing them. So we were also analyzing how long is actually the waiting time between two lots being like, merged together. So this graph here shows you the wait time distribution for every batch, meaning like after combining the lots together. So what is shown here is that most of the batches were actually had a wait time of only 36 minutes. And this is like very low. This means we could have like easily merged, waited only like half an hour before merging two batches together or merging two lots together. By the way, this is a mistake on the far right. It is supposed to be 8 hours because this is the time frame we were like analyzing, right? But this graph shows you that we didn't have to wait 8 hours. It's like totally fine by waiting only 1 hour. Okay, next. So our summary, we found the method of merging lots together before, or rather maximizing the capacity of each of those lots is like a very efficient method of saving water, obviously, but also that it actually does not affect the processing of the wafers too much because like waiting half an hour for the next lot to arrive can be like, it does not obstruct the processing very much because there's very little time on the whole time scale of processing of wafers. And by doing that simple step only, we could have saved the water usage by a really significant number, by 23%. And of course, saving water not only is a good thing in itself, of course, but also it has a lot of further positives, for example, in usage of or reducing energy consumption as well as chemicals consumption as well. So it's like a very good thing to do.